When you think of earthquakes, the east coast of the United States is not the first place you think of them occurring. However, areas east of the Rockies aren't immune from them, and there are a few seismic zones of concern that can possibly create a large magnitude earthquake. Let's explore this risk. An earthquake is defined as a sudden motion or trembling caused by an abrupt release of energy inside the earth. When energy is released, it's transmitted by what's known as seismic waves. There are three main types of seismic waves generated by earthquakes: primary waves, P waves, secondary waves, S waves, and surface waves. Each type has distinct characteristics and effects as they travel through the earth. P waves are compressional waves that arrive at a location first, and they can travel through both solids and liquids. Following P waves, S waves are slower and can only move through solid materials. These waves are shear waves, moving the ground perpendicular to the direction of wave propagation. Lastly, surface waves travel along the Earth's surface and are slower than body waves. Surface waves are responsible for most of the damage during an earthquake, as they have higher amplitudes and longer durations. There are two main types of surface waves: love waves, which move side to side, and Rayleigh waves, which cause a rolling motion. Most earthquakes take less than a minute to occur, but if the magnitude is high, they can cause severe to catastrophic damages. Seismically, areas that are located on or near tectonic plate boundaries are at the highest risk from receiving earthquakes. This includes three types: divergent plate boundaries, plates that split apart; transform plate boundaries, plates that lie parallel to one another; and convergent plate boundaries, plates that come together and compress. The east coast of the United States is not located near any of these types of plate boundaries, so when an earthquake does occur there, it's called an intraplate earthquake, one that happens within a tectonic plate. In this week's episode, we are going to explore the possibility of a large East Coast earthquake. We will review the geographic areas of most concern and the earth science behind why large earthquakes are a possibility within these zones. Later on, we'll discuss how these areas can prepare for future earthquakes. Before we begin, if you enjoy geography and earth science, you found the right channel. So be sure to subscribe to my channel, Our World, Our Planet, Our Home. Let's get started. The geomorphology of the eastern United States is significantly different from that of the west, in that there are fewer mountains and rugged terrain areas. Usually areas such as those have numerous faults that are connected to a plate boundary, as in the case of the Cascade Mountains, or individualized interplate faults as are found in the Rockies. The eastern United States' largest mountain chain is the Appalachians, which stretches from Maine to Alabama, and there are relatively smaller mountains and hills within other states here. While these are small and within a plate, there are some areas of seismic activity. Take a look at this USGS seismic risk map. The most obvious thing from it is that the western United States has a way higher risk than the east of seeing a major earthquake. However, the east has high-risk areas. Let's review those, from northeast to southwest. In New England, in the states of Maine, New Hampshire, and northern Massachusetts, there is a moderate to higher risk of an earthquake. Westward, extreme upstate New York, within the Adirondacks, and in the lower elevated area at the U.S.-Canadian border, has a moderate to high risk factor. Heading south, the next area of concern is within the New York metropolitan area, which does experience its strongest earthquake in over 200 years, on April 5, 2024. This region has a moderate risk factor for seeing a future earthquake. In the Mid-Atlantic, the state of Virginia has two moderate risk areas, one which did experience a strong 5.8 magnitude earthquake in 2011. But the most worrisome areas of potential seismic activity are in the southeastern United States and the south-central Midwest. First, coastal South Carolina around Charleston has a very high seismic risk, and the area was affected by a major earthquake in 1886. Westward, eastern Tennessee, within the Blue Ridge Mountains, has a high risk of seismic activity. But the most notable area of seismic risk in the eastern United States is within southeastern Missouri, western Kentucky, western Tennessee, and northeastern Arkansas, known as the New Madrid seismic zone, which saw 3 consecutive high-magnitude earthquakes from December 1811 to February of 1812. Other unusual areas of seismic risk are within central Oklahoma, which historically has not really had earthquakes. Now that we know the locations where potential East Coast earthquakes may occur, let's take a look at the geology, starting in the Northeast. Near Quebec, parts of upstate New York are associated with the St. Lawrence Rift System as a result of ancient rifting events that occurred approximately 450 to 600 million years ago, during the breakup of the supercontinent Rodinia and later during the opening of the Iapetus Ocean. This rifting has left behind deep fault lines and basins filled with sedimentary rocks. Some of these fault lines are still active, leading to a greater probability of an earthquake. The Ramapo Fault System is a major geological feature in the northeastern United States, particularly affecting parts of New York, New Jersey, and Pennsylvania. It plays a crucial role in the region's geology and seismic activity. The fault itself dates back to the Paleozoic era, roughly 450 million years ago, when it was a thrust fault associated with the creation of the Appalachian Mountains. Later, around 250 million years ago, it was reactivated when the rifting of the supercontinent Pangaea began. Nowadays, the fault isn't extremely active, but on April 5, 2024, it triggered a magnitude 4.8 earthquake in Tewksbury, New Jersey, the second largest earthquake ever recorded in the state. Afterwards, dozens of aftershocks occurred, with the 3.8 magnitude one occurring the same day as the main event. Due to its potential threat to densely populated areas, the fault system is closely monitored by scientists. On to the Mid-Atlantic, the Central Virginia seismic zone is quite similar to the geology of the Ramapo Fault System, in that it was connected to the creation of the Appalachians and the breakup of Pangaea. In the case of the 2011 earthquake, it is believed that these tectonic stresses led to the reactivation of one or more of these ancient faults. The 2011 earthquake was a 5.8 magnitude, which is abnormally strong for the East Coast. In South Carolina, the Charleston seismic zone is considered a very high-risk area for a future earthquake. Geologically, it's quite similar to the Virginia and Ramapo seismic systems, with it being associated with the creation and breakup of supercontinents. The 1886 Charleston earthquake was the strongest earthquake ever to hit the East Coast of the United States, with an estimated magnitude of around 7. Also, there isn't much geological evidence of other earthquakes occurring in the area, which is rare. Besides the immediate coast, other inland areas of the eastern United States have a moderate to very high risk of getting earthquakes. One of the most ominous areas is the New Madrid seismic zone in proximity to 5 states: Missouri, Illinois, Kentucky, Tennessee, and Arkansas. The seismic zone lies in the failed Reelfoot Rift, which is an ancient rift from the Precambrian era, formed around 750 million years ago. This rift was initially created when the North American continent began to split apart, but the rifting process failed, leaving behind weakened zones in the crust. The most famous seismic events of the New Madrid seismic zone occurred during the winter of 1811 and 1812. These events included 3 major earthquakes estimated to be between magnitude 7 and 8, with aftershocks felt widely across the central and eastern United States. Today, the area is still regarded as having a very high risk of seeing future earthquakes, and what's more concerning is that there haven't been many very large earthquakes since the 1811 and 1812 ones. So, this may mean that the area is overdue for one. Besides naturally geologically active areas east of the Rockies experiencing earthquakes, there are some potentially unnaturally created ones. Fracking, or hydraulic fracturing, has been linked to an increase in earthquake activity in the Midwest, especially in Oklahoma. Fracking involves injecting fluid at high pressure into shale formations to extract oil and gas. The wastewater generated from this process, as well as from conventional drilling, is often disposed by injecting it back into the ground into deep wells, which is thought to be a safer disposal method in terms of surface contamination and storage. However, this injection can increase underground pressures, lubricate faults, and make them more likely to slip, causing earthquakes. In the last 20 years, Oklahoma has had 5 earthquakes with a magnitude of over 5, with the strongest being on September 3, 2016, measuring a 5.8. While eastern U.S. earthquakes are not very common, being prepared for them is still necessary. One geological reason for this is how far East Coast earthquakes are felt compared to West Coast ones. The geological structure of the East Coast features older, colder, and more rigid rocks that transmit seismic waves more efficiently than younger, hotter, and more fractured rocks of the West Coast. This means that the seismic waves can travel further without losing as much energy. If this is the case, more cities and metropolitan areas will feel the shaking, creating possible hazards. For areas closer to active interplate fault lines, infrastructure integrity needs to be addressed. Lots of coastal East Coast cities, such as Boston, New York, Philadelphia, Washington, D.C., and Charleston, South Carolina, have older buildings, road networks, and bridges which may not be capable of withstanding a large earthquake. New York City, the largest of the cities mentioned, has updated to include considerations for seismic activity, but widespread retrofitting of older buildings, specifically for earthquakes, is limited. The Virginia earthquake of 2011 that damaged the Washington Monument and the National Cathedral raised awareness about seismic risk in the area. Following this, there was more focus on assessing the seismic vulnerability of buildings, especially historic ones. Nonetheless, comprehensive retrofitting across the city is not common, although critical structures in new buildings are designed to meet more stringent codes. Unlike the other cities mentioned, Charleston, South Carolina is more familiar with the threat of earthquakes, having experienced a major earthquake in 1886. Charleston has been more proactive in terms of seismic retrofitting, especially for its historical buildings. The city enforces modern building codes that include seismic considerations, and there have been efforts to retrofit historically significant structures to withstand earthquakes. Memphis and St. Louis, 2 highly populated urban metropolitan areas closest to the New Madrid seismic zone, have also retrofitted many of their buildings to withstand stronger earthquakes. Other than retrofitting infrastructure, other precautions include awareness of seismic risk. While uncommon, the 2011 Virginia earthquake and the 2024 New Jersey earthquake did make people within those areas aware that earthquakes do happen. And by living in the 21st century, technology associated with seismic sciences is becoming increasingly advanced. While seismologists can't predict when an earthquake will occur, methods such as foreshock monitoring and fault analyses can give a better picture of potentially future earthquake events. If technology increases further, perhaps seismologists will finally be able to accurately predict when and where an earthquake will occur. Earthquakes are natural forces of nature that occur every day on Earth. Around 55 earthquakes happen every day, with most being small in magnitude, but there are the minority that are strong. Even in the most seismically active interplate fault areas, people living there may never experience a strong earthquake. However, it is best to be prepared for that scenario. That concludes today's episode. Thank you once again for watching. If you want to leave your feedback, please do so in the comment section below. And remember to subscribe to my channel, Our World, Our Planet, Our Home. Until next time!